Hello, everyone. How are we doing today? I trust we're all doing awesome. You can feel free to just say we can hear you loud and clear. You can hear me. Just chat and say um, we can hear you. You can hear me clearly. Yes, get your feedback. Can you hear me clearly? Okay. So I'll need to get the feedback. You can all hear. So I'll need to get the feedback. You can all hear. So I'll need to get the feedback. You can all hear. So I'll need to get the feedback. You can all hear. So I'll need to get the feedback. You can all hear. So I'll need to get the feedback. You can all hear. So I'll need to get the feedback. You can all hear. So I'll need to get the feedback. You can all hear. So I'll need to get the feedback. You can all hear. So I'll need to get the feedback. You can all hear. So I'll need to get the feedback. You can all hear. So I'll need to get the feedback. You can all hear. So I'll need to get the feedback. You can all hear. All right. Can we all hear me? If you can hear me, please just let me know. In the comment section, yes, you can. Okay. So you can all hear me clearly. I need to verify, so I don't just go on talking while you don't really get what it's been put forward. Okay. So based on that, I'll start up right. All right. So basically, we are looking at how to write research papers in computing sciences. And how does writing research paper in computer sciences differ from writing such papers in other fields, basically? So one of the key things would be looking at is how do we even get started? Of course, we'll be having a series of this and we'll be building one on top of the other. And over time, we'll get to have, full-fledged work running all through. But for now, our focus is how do we get to write research papers in the computing sciences. So you are there, you want to write a paper. How do you get started? What and what do you look at? What would be your focus generally? What are the things you would have your mind on? What will you be your point of attention? If you're writing papers generally. So from that, let's just get started. But before we move further, I'm saying that I have just 13 people currently present. I'm expecting to have at least about 40 to 50 of you. So let's even say we should be hitting numbers around 30. So where are the others? Where are the others? Inform your colleagues. I'm still here. I'm waiting for the others to join. The clock is fast ticking. I'm having just 13 of you. I will not keep touching base back and forth. The idea is that you'd be able to ask questions and get so so please inform your colleagues they need to join. Inform your colleagues they need to join. Don't keep going in and out. Just join and stay in so that I can see the numbers as they rise, and when we hit 25, I can get started in full and then just move on. So if I'm expecting about 50 of you, so I'll just stay put when we hit 25, then I'll get started and I'll do a scenario where people ask questions and that we are unclear about. Of course, we can at the end of the day be able to put things together and make a whole from everything. We are just 19 now. Where are the others? Inform your colleagues, let them join. Need to be 20. Need to be 20. Need to be 20. We need to be 25. So where are the others?
Okay. So now, okay.
Okay,
So
um,
now we just
just
proceed.
proceed.
Okay.
Okay, so okay.
And
Basically,
basically,
I'll
I'll
be
be
taking
taking
us
us through.
through
The
the
idea
idea
here is
here
for
is
us
for us
to
to
have a
have
walk through
through,
the playbook. So
so
we'll just
we
walk
just
through
walk
it,
through it,
and
and
hopefully we'll
we will
pick up
pick up
things from
things
it.
from it.
So
So
if
if
we
we
all
all
have
have
the
the
playbook,
playbook, we
we
could
could just
just
open it
open
up,
it
and
up and
let's
let's
start
start
working
working
from
from
there.
there.
I would open the
Open the
playbook here,
playbook here,
and
and
I'll
I'll
share, and
share,
from
and from
there I'll
there
just
I'll
move on, so that we can get to see
get
and
to see and
appreciate
appreciate
each
each
of
of
the
the
concepts
concepts.
being discussed. Okay,
Okay,
so we'll
so we'll
start with
start with
playbook
playbook
one.
one.
We remember playbook one. It's basically an introductory concept into the
The
overall
overall
research work. So, playbook one. If you
if
have any issues,
issues,
any
any
questions,
questions,
please feel
please feel
free to
free to
just
just
ask.
ask.
We'll
We'll
just
just
move on
move
with
on
the
to our
same.
same.
If you have
If
a
you have a
question,
question, you could
ask,
ask,
and then
and then
I'll
I'll
just
just
answer them
answer them
as
as
it
it
goes.
goes.
So
So
let me
let me
share
share
my
my
screen so we
screen so
can
we can
see
see
playbook
playbook
one
one
and
and
how
how
we're
we're
going
going
about
about
it.
it.
Okay.
Okay. Okay. Like one.
Okay,
Let me share. Let me share
my
my
screen
screen so we can.
let me
Let
share
me
the
share the
playbook
playbook
one
one so we can work with it
and
and
just
just
make do
make
with
do with
it.
it.
Okay,
Okay,
so
so
we
we
have
have
this.
this. Okay. Can we all see the screen? I guess we all can.
All right.
Right.
So
So
this is the
this is the
playbook
playbook we're
we're
working
working with
with
at
at
this
this
point
point
in
in
time.
time.
And with
And with
this,
this,
we're
we're
just
just
looking
looking
at
at
the
the
different
different.
it's
It's
like
like a
a playbook
playbook that
that
looks
looks
at
at how
how
we
we
can
can
conduct
conduct
research
research
in
in
AI,
AI,
machine
machine
learning,
learning,
deep
deep
learning,
learning,
data
data
science,
science,
large
large
language
language
model,
model,
multimodal,
multimodal,
and
and
Gen
Gen
AI
AI
generally.
generally.
So
So
we'll
we'll
just
just
walk
walk
through this,
through this,
and
and
hopefully by the
by the
time we're
time
through
we're
with
through with
this,
this,
we'll have
we'll
a
have
more
a more
holistic
holistic
picture
picture
of
of
what
what
we're looking
we're
at
looking at
entails.
entail.
All right.
All right.
So
So
can we all
can we
see?
see?
I
I
guess
guess
we
we
can
can
all
all
see
see
this.
this.
Okay.
Okay.
So
So
now
now,
here's a
this is a
comprehensive
comprehensive
playbook
playbook
and
and
guide for
guide for
conducting
conducting
world-class
world-class
research in
research in
AI,
AI,
machine
machine
learning,
learning, data,
deep
deep
learning,
learning,
data
data science,
science, and large
and large
language
language
model.
model.
So,
So,
in
in
this,
this,
we are
we are
looking at
looking at
quite a
quite a
number of
number of
things,
things,
um,
um,
including
including
identifying
identifying
research gaps, basically formulating research questions, data set selection and preparation, model selection and development. We're looking at experimental design and evaluation. We're looking at implementation and prototyping. Then we'll look at collaboration and open source contributions. Then we'll look at publishing and dissemination. Then in addition to that, we also look at funding and grant applications and ethical considerations, and then we'll look at continuous learning. So I'll try walk through this pretty fast so that we're able to cover quite a lot. So looking at identifying research gaps, basically, the idea with regards literature review, writing a thesis or a research work, generally, a lot of people tend to start from chapter 1, which tends to be a logical thing to do. You could think of it like, okay, it's a logical thing to do. You start from chapter 1 and move on from there to other things. But realistically, your research work should start from chapter 2, because it's from chapter 2 you get to build contexts around which you really get to get your work done. So what does chapter 2 entail? Chapter 2 basically entails literature review. Literature review. You review your literature, you conduct a thorough literature review in your interest, utilizing platforms like Google Scholar, IEEE Explore, and different other platforms that databases where you can get to find useful materials. So the idea is, let's say, for example, you have a topic, a research area of interest you'll be working on. The idea generally is to look for topics that are similar to that topic. And the idea behind that is to see what works have already been done in this area, and then now figure out what are the other areas where gap exists, where we could possibly, create value from. So generally, research work has to do with, in most cases, filling gaps. So you're conducting your work, and there's a gap somewhere in between. And you have a particular domain where research is being conducted, and within that domain, there are gaps. And the idea is to fill in the gaps. Okay. Oh my. Sorry, it seemed like we've lost the... Are we still seeing my presentation? If you're still seeing it, just let me know. If you're not, okay, it seems like I've lost focus of the screen at the moment. Okay, give me a minute. Let me recapture my screen and get back. Give me a moment. Let me recapture the screen and get back. me? Can you hear me? Or were you just looking at this? Was the audio clear? I need to be sure of that before I move on. Okay, okay. Um, let's see. Okay. Well, I guess you can all hear me now. All right. So, yes, you all can. That's good. Okay, so okay. All right. Sorry, I'm just taking a look at if you please give me a minute, I'll be right back. Okay. So, sorry for that break. There was there's been some glitch here and there. So I was basically just trying to get the whole thing up and running. Let me just run through this quickly so we can just appreciate the whole thing and move on. So I had some technical issues. Sorry about that. I want to believe we can all hear me loud and clear. If we're having issues, please can you just signify? I want to believe there are no issues, but if peradventure there are, can you just signify? If perhaps you can't hear clearly. Okay, so I believe we can all hear me clearly. Okay, so on that premise would continue. So okay, so we said earlier on. Sorry, I just got clicking on a few things on the screen and things just went off at some point. So basically, from existing works, if you are an undergrad student, it's pretty easy to. Okay, let me just switch to video so we can have more of a one-on-one talk rather than going through slides. I think that would be a whole lot better. Let's make this more interactive. I was going through buttons and what's happening. I just found myself on a different page and back up again. That what and what is the how do we get our work up and running? How do we get our research work? And like I've already mentioned, one, I want to be interactive. At least that way we can rather than working the playbook itself. But everything that we here is anything that we have in the playbook, and the idea here is to make it more interactive and ask more questions. Could be quite so just allow me this talk to this, and you have questions, you could just feel free to ask your questions. Okay, so generally when you're going through research papers and you have your research questions and all that, the gaps identified from the paper. Also for undergrad students, for instance, who are not very familiar with some research methodology, you get to see, of course, you have been introduced to the before ever you get the points of your research work. What happens? Yeah, you make sure that you go through it, right? And you can apply work. You have to see several different methodologies adopted. You see how they got their work done. You see how the approaches they use. basically you can simply adopt the same method. And the interesting thing is that to a large extent, in fact, you could just put a few things to come up with your own discoveries. Basically, you do things like maybe the data set that is used for the research. You could have use almost exactly the same method, the same approach. Say you find a paper that was used by an established author. The author is pretty established, so you know what he's saying. He knows his approach. So you're pretty confident. Okay, so sorry for that. So the point here is you seek a work by an established author. Say you are conducting a research, and the idea is to look at works that have already been done by already established authors, see the approaches they took in performing conducting our research, see the methods they used, and then since you're learning how to conduct your own research, you could just simply adopt their own method basically, and perhaps try out different data sets using their method. A good approach usually would be to actually try to replicate their own research work, right? They've done something, you've seen what they've done in real time, you've seen their work. It's pretty interesting, it's fine, it's clean, it's crisp. You could try to replicate that work first, and only after you've been able to replicate your work, you've been able to set up your own research table, your research desk, you've set up your tools, use their own same data set, and you're able to get about the same result you were getting. Then, of course, that could give an idea that, okay, you're fully set up. Then you could now try out, say, a different data set. Or say you could now try out, peradventure, different algorithms on perhaps even the same data set they had used earlier on, or in this case, different algorithms using the same data sets, or different data sets with some algorithms, or different algorithms, different data sets, just trying to make sure that you follow the same methods that have been used by previous works, see if you can replicate the results, see what outcomes you get with the sets you're working with, and basically that a good incline to whether the research methods you are using. Like I said, the idea is to look at existing research work done by established researchers that has gone through peer review. You're looking at peer-reviewed work here. So since it's a peer-reviewed work, it's not just a case of it's the work has been done by a particular researcher. When we say peer review, basically it simply means that the paper, when I say paper here, you have you want to conduct a research, for example, and in conducting this research, you want to see what existing research works exist in this particular domain. Now, in saying what existing research works exist in this domain, you want to see existing publications. Now, in choosing what publications to use, you need to look for valid sources, sources where that have pretty high reputation for publishing high standard work. And of course, they must be peer reviewed. And peer review simply means that the research work, somebody else has looked at the work and established that the work is good and can be the output of the work can be considered reliable. Based on that, you can now decide to use that work for your own research. So the idea of peer review simply means somebody else who's equally an expert in the field has also taken a look at the research work and have validated that the research work follows proper method. Laws can be considered to be reliable. Basically, that's the idea. Okay, so that's the idea. So now, if the methods are dependable and reliable, they follow standard approach, then it simply means if you apply the same method, you will equally be following standard approach and hence you'll be conducting a reliable research. Basically, that's just the idea. Now, with regards to many of your project works, in natural language processing, artificial intelligence, AI, machine learning, of course, this is a trend now, and conducting research in these areas tends to gather a lot of interest. So, whether you are in computer science, or you're in cybersecurity, or you're just trying to decide on which field to latch onto altogether, it would be a good idea to conduct research in these areas. Conduct research in, if you're in cybersecurity, you have AI being used extensively in security. And if you come to science, you have AI, machine learning, and the rest being used extensively in solving real world problems. So the idea of large language models, LLMs, data efficiency, multimodal learning, integration, and efficiency of multimodal learning. Multimodal learning simply has to do with you applying different modes in the learning approach. You combine different things, and then you could integrate Gen AI, in your workflow and all that. Basically, that's just it. So if after you've gone through your chapter 2, you've done a literature review, you've been able to identify gaps in existing works, you've been able to see what methods, what approaches were used by current researchers, established researchers, you've seen what methods, what approaches were used, then you are able to say, okay, some of you are saying it's cracking really bad. You can't hear me. Okay. Is it still cracking? Can I get a feedback? Is it still cracking? Okay. Okay. I'm wondering why it's cracking real bad. Okay, some people say they can hear just fine. The audio is good. Okay. Okay, it could, yeah. Okay. Okay, so I think it might have to do with maybe your network as well. Okay, I think what I'll do is I'll just slow down on my pace of speaking. That way, I'll slow down on my pace of speaking. That way, it can transmit across to everyone evenly and smoothly. But the idea of if we can all still hear me, I'll just slow down my pace. Please let's just take it slowly. If it's getting real bad and you can't hear me at some point, just send a message as well. And I'm looking at the messages, so please just send them in. Um, but for those of us who are present and are following, we must get value from today's session. So the idea generally is that we begin our research work from chapter 2, right? Begin our research work from chapter 2. Please pardon, I might look like I'm not facing the camera directly. The camera is overboard, so my screen, my laptop screen is down. So it's actually my laptop screen I'm looking at. So if it looks like maybe I'm not looking at the you directly, is because actually looking at the laptop screen. So please me on that. Okay. So the and of course that will help me keep track of I'm using a camera different from that of my laptop. So that's why it might not look like I'm looking at the screen directly. Okay. So the idea generally behind today's the main concept today is that our research work not from chapter 1 but from chapter 2. That is very key. Trying to begin from chapter 1, it's going to be pretty difficult to have trying to really draw up a strong research problem. And if you don't have a strong research problem you're trying to solve, that's a big issue, because your entire research work is based on the research problem. So it's pretty important that we take of this step. It's very, very important. From your research from chapter 2. Chapter 2 is your literature review. So it's only after you have reviewed existing literature that you can now go ahead to draw up a research problem, of course, based on the general trends you have seen and general problems that tend to have been raised from the general trends you have seen. Also, I've explained what kind of literature to go through. You go through peer-reviewed literature. You go through research databases. You could find reputable materials on Google Scholar, on IEEE repositories like IEEE Explore, on Scopus, on reputable websites. You could do a search like, best research databases in computer science, for example. And that would bring up the different databases like IEEE Explore, the different maybe Scopus-based research journals and databases and so on. And then based on those, you can now begin to do your search. So basically that's that. Like I've said, deciding on what research to work on is also pretty easy, especially for undergrads, because you could simply look at, once you found a reputable journal or database, you retrieve reputable articles, reputable journals from those databases, see what they're saying. You can pull out like say 20 works that are related to the work you are interested in, that have about the same topic, similar topic. Pull out about 20. Then based on those, you can now begin to narrow down on precise topic. So you already have a topic, a domain you've been supplied. Based on that, you search for research topics in that area. Now, based on your findings on those research topics, you've seen problems that will help you to refine that topic you have initially. So when you have a research interest in mind, it doesn't mean you must follow that research interest or a research topic. You'll be given a research topic, It doesn't mean that has to be the final topic you end up with. Although it's generally advisable that you don't stray too far, but by the time you read through existing literature, you go through existing works, reputable journals, reputable conference papers, you might begin to have new insight. You might begin to see new problems you have discovered. You might begin to see that the initial concept you had in mind, there might be some more precise approach to it. And then that will now help you refine your topic even further. Say, for instance, including in the topic what new method you have decided to adopt in your research. So that in itself brings a whole new spice to your research topic. And generally, that would really help. Do we have any questions from what we've looked at so far? Any questions? If you have any questions, feel free to just ask the questions so we can move on from there. There are a whole lot more to say, even from your playbook one, but the concept we have just discussed is so important that if you have a good grasp of it, yes, it will still be up, so you can rewatch it. But the beauty of the live session is that you can really get to ask questions live, and I can get to answer you live and direct. Yes. So you can get to ask your questions live, and I get to answer you live and direct. So please, if you have questions, you can ask. That gives you a lot of benefits against those that will be rewatching. So please feel free to ask. Other things I could put forward and just discuss, but I don't want to just keep going on and on talking when there might actually be things we don't understand. So okay, I'm waiting for your questions to roll in. I see there are no questions. So if there are no questions, we'll continue then. Okay, if there are no questions, we'll continue. Right. So, how do we formulate a research question? You've gone through your chapters. You've seen you've seen methods, approaches that were used by more experienced researchers that have worked in the same field around the same topics. You've seen the exact methods they've used. Perhaps you've been able to even replicate their work. When I say replicate, I mean be able to set up, replicate the setup they described in their research work. You're able to duplicate it to be able to get the same kind of results they got. Let's assume that every of the methods and data and every of the approach and tools they use are publicly available. They are not proprietary, so you have access to them. If that's the case, then you can gain access to all these tools, all the data sets, and you can put them together. And based on the data you now have, you are able to conduct the same research that the researcher in the work had already done, and then get the same results they got, which of course is why you should conduct research and publish your work so that other researchers can replicate your work and be able to build on it. So you are now in a position to decide, okay, you've gone through this, you've produced the same work. You can decide there and then to try out different things, try out different data sets with the same method, with the same setup. Try different data sets, see what you get, see the variations in output. That in itself is research. Or using the exact same data set, you could decide to try out different algorithms. You have different algorithms you could use for your research. So you've already replicated the setup that was described in the research. Like I said, you could try out a different data set on the same algorithms used in your initial research, the one that was in the papers you have gone through, or you could use the same data set, but use different algorithms on the same data set, whichever way. Or you could even use a different approach altogether. Of course, in the papers you've looked at already, the majority of them have described certain problems that are happening across the research work. So, looking at these problems, you could decide to tackle any of them. You've gone through, say, 20, 30 different papers, maybe more or less, and you've seen a common trend. You've seen they all making mention of a particular problem, and you're like, right? It's takes something up, like read 1, 2, 3, 4, 5 papers, and across the board, maybe out of 10 of them, a particular problem is mentioned across 5 of those papers. That tells you, this is a problem worth looking at. So you could decide to now focus your research work on addressing that issue. If it's something within where you think your ability to, that's an approach as well. So using this method, you could decide and yes, I can say most of our research are AI based, and I am right most AI related research. Okay, as of 2021, it's difficult to replicate existing research as there are limited topics online. So what and how do we go about that? Okay. A lot of research. AI might be having a buzz now, maybe it's a real buzz now, but I can assure you, I can very much assure you that research conducted even way back have employed AI-based approaches. So I'm encouraging you to engage in AI and machine learning-based research because they tend to help you solve a lot of problems much faster, provided data is available. So once data is available, you can get to conduct your research pretty easily, pretty quickly, and you're good to go, right? So it's either you are in cybersecurity or you're in computer science, you could really leverage AI to your advantage a whole lot. And the beautiful thing is that you can leverage already existing models. So there are works way back that are hinged, that are premised on AI. So please be rest assured that you would find more than enough research papers that employ AI-based approaches in addressing the concerns which they address. You would find more than enough, if I can assure you of that. So don't let that be a concern. Don't let that be a concern. If you have a particular topic and you've been trying to get you've been struggling to get research papers, you could put your topic right here, right now. You would get more than enough papers, right? And Google is still very valid. Like I mentioned, just use Google to look for reputable, the best databases in computing sciences. I've mentioned a few of them. You could just use that. Okay, so I think that's the entire point of this research. We're gonna have to figure it out. Okay, yes. The idea is why it's called research. Yes, Moses mentioned. He said that's the entire point of this research. You have to figure it out. Moses, that's correct. So please don't think that AI is a new concept. AI, machine learning, they've been around for years, right? The buzz is just catching up. It's just catching up. Exactly. Say might actually find something unique, a study that you own. Fantastic. Moses, thank you for that. Thank you for that. Thank you, Moses. Thank you, Moses. I'm saying it again because you're making my work very easy here. So now this is Moses saying you might actually find something unique, a study that you own. Thank you, Moses. I can't find a better word, a better way to put it. Moses has put it perfectly well. That is the idea behind the research. You've been given a research topic. Like I said, it's a working topic. You know, it's not cast in stone. It's not cast in stone. So you have to take it and actually take ownership of it. That's actually the idea. And you cannot take ownership of what you don't understand. So it's when you've done the first step I mentioned, that is starting off with your chapter 2, which is the literature review. That's when you get to really understand what you're working on. At that point, you have not really delved into your main research, but you have delved into what other people have done on this research topic, right? That's the main idea. You've delved into what others have done on this topic, and based on that, you can now begin to take ownership. To be honest with you, when you're conducting research, to a large extent, many a times, it gets to a point where your supervisor will be asking you questions. By the time you've taken ownership of the research, your supervisor, yes, he's an authority in the field, but you now be more of an authority in your own domain because you would have done extensive research. Hence, your supervisor's work will now be to guide you. Okay, what papers have you studied? What are they saying? What problems did they identify? What methods did they employ? You see, you have the answers to this question, but then your supervisor now begins to guide you to make sure you have extracted the correct information from this thesis, from the different theses, different publications you have gone through, and I've given you sites and sources and databases where you can go and get the reputable resources to work with. Like I mentioned earlier on, I mentioned to some of you earlier on that I was going to make a full-fledged course from the table to help you be able to go through the sorry, I'm having a beeping. You'll have to give me a minute. Let me just I'll be back in just a minute. Okay, so yes, I'm back. Thanks for waiting up. So, like I mentioned, it's right to take ownership. All right. So, okay, I'm seeing that also at the end of the project, will it just be a research or an implementation as well, like a physical project? Right. There is something Moses mentioned in his comments that made me say it's I could hardly add more to it. He said you might actually find something unique, a study that you own. Taking ownership of something, um, typically you wouldn't want it to just be um, a mere. You want the life cycle of that thing to just end in a paper. To a large extent, you would want to make it available and accessible to people, right? So, to a large extent, we advise and encourage that when you conduct a research in the computing sciences, you should make it such that you can develop a solution from it, implement something that can bring out the beauty of your work. Say, for instance, you'd create a research to see you developed an algorithm that is able to effectively predict fraud using, let's say, facial detection, let's say facial expression detection. So let's say you have a system that continually monitors the facial expression of individuals, and the system is able to detect that fraud is about to happen based on the expression on the individual's faces. As beautiful as that output would be, it wouldn't be too useful if the research work is not implemented and tried. It's not put out there to be used. In fact, to really test the efficacy, the effectiveness of your work, typically you would have to develop like a tool, right? A tool within which your model is implemented. And typically that tool would be like an application or some form of software. Even if your research output could be implemented like some form of API. You've already conducted the research, right? You've done your findings, you've done your tests, but now you want to make it available. Just build an API around it, and perhaps about build up an application, maybe an API, and then you have a front end that consumes the API, or you just build a standalone application. It could be web based and all that. That would just simply implement that. That would help. So you say at the end of the project, would it just be a research, or would you build an application or implement one? Yes, you should implement. You should implement, because that's the way to really get to showcase your work. You should implement. Not everybody would be able to go to the back to set up your research and all that. But you've implemented your research, you've built models, right? Remember, like me, for most AI projects, what you end up as your output many times would be developed models, right? Develop models, and then you could now take those models and implement them in a solution. So implement them in an API, which can be called from a front end to perform what, to demonstrate effectiveness of your work, or maybe a simple standalone solution that would work. You say, what if there is no research or field? None of you has a topic that does not have a research already done in your field. You get, and like Moses mentioned earlier on, he said, I actually find something unique, a study that you own. But as I speak to you, none of you has a research topic that has not been done, or that doesn't have any work around it. And if you think your topic falls in the category, that you have a research work that no one has already done anything in that field, please post your topic. Let's look at it. And before I leave here, I'll show you at least 10 different works that have been done around that area. So none of you has a topic like that, but you should still try to own it. So what if there is research already done? No research cooked. Okay, I don't know what you mean by cooked. Interesting, real. Okay. Please make your comments clear, because I don't really know what you mean by cooked, and I don't know. I don't know if you want to explain what you mean by cooked. So I'm not getting it. I want to be able to follow your comments to deliver more value. Yes. So I really don't know if you have a topic like in that category. So you shouldn't bother about having a topic that doesn't have any work currently done in that area. It's not the case. It's not the case what you have. Okay, so for playbook 1 today, do you have any questions before I move into the rounding section of this? Playbook 3. You get playbook 3. I'm actually building a course. I'm building a course around these playbooks, so that if you have questions, you can simply refer back to contents of the course. It's still the same content in the playbook, but down to smaller sections. Okay, so broken down into subsections, and that would help, right? So the idea here is to present the different approaches. I'll send you the link to the course when I'm done building it. I already have the platform set up, so I'm just adding content to it. So I'll send you the link to the course, and basically you take the course and you take some assessments on the course to demonstrate the fact that you've gone through it and you understand the concept. So playbook 3, you get playbook 3 in the course as well. So you get the course, it's a full-fledged course. You just come into the course, you register, and then you take the course, you have to research concepts, and then you have everything up and running. So yes, you have playbook 3 available to you within that. Okay, if there are no questions, let's move on to the round. So formulating research questions. How do we formulate research questions? So you address high impact problems or limitations identified in your review. To formulate research questions, basically we're talking about identifying problems. What problems you want to solve. Basically, we're talking about research questions. We're talking about identifying questions that look at the problem you're trying to solve. So you look at high impact problems or limitations identified in your review. You've reviewed literature already, you've seen problems mentioned, which of them are of high impact, you address them. They reflect novelty, that is pushing the boundary in one or more areas like model architecture, efficiency, or real-world usability. Now, let's know, if we don't already know, that you could build systems. You could build systems in software engineering, in computer science, But if the systems are not efficient, it doesn't really help. It doesn't really do much. So the idea is that we build systems that are efficient, that are effective, that um, can be usable in the real world, basically, and then be measurable and testable with either existing data sets or bespoke data. Basically, those are the things you use to decide on the problems you want to work on. Now, deciding on data set selection, what data set do you work with? We have quite a number of public data sets like Kaggle. You can find data sets on repositories like Kaggle, Hugging Face, Google Datasets, OpenAI API, and so on. So you could equally find data sets, from different. You could combine data from different data sets, for example, to create your own data set. That's a custom data set. You could create one. So that is, if, say, for instance, you're trying to get data and where appropriate, you could do that. You could gather domain-specific data using APIs or web scraping. Then you could you could label data accurately, especially if working on a multimodal or a Gen AI project, you label data. Then you can clean and pre-process data for consistency. That is, you remove duplicates, normalize values, and then handle missing data, basically. And then best practices include data augmentation techniques for small data sets. That is, when you have small data sets, you may want to augment the data, so that it can be larger. Then for NLP-based research, NLP stands for Natural Language Processing. For such research, you could want to ensure pre-processing text, such as tokenization, stemming, lemmatization, and so on. And then you could also use embeddings like Word2Vec, and then BART and GPT embeddings or vector stores, basically for efficient information retrieval. So these are these are to handle data sets and all that. Now for model selection, we need to look at state-of-the-art models, focus on cutting-edge architectures, for AI, machine learning, deep learning. We could look more at architectures around transformers, diffusion models, CNN, and for NLPs, for language processing vis-a-vis large language models, we could look at GPT, BART, T5, LLMA, and so on. And then for multimodal approach, we could use Clip, Flamingo, Perceiver, Florence. And then for Gen AI, we could use things like tools like the E architecture, then the Mid Journey, Stable Diffusion, and so on. So these are tools, and they are the playbook. So just take advantage of this listed. Depending on what our topic is, you can see that these different topics have been highlighted, mentioned based on what area of research you're working on, right? And with regards to optimization, you could focus on fine-tuning pre-trained models. That is, you already have pre-trained models, you could now fine-tune them using the concept of transfer learning. We have different types of learning, right? And transfer learning is one of those types of learning. So, or you could develop from scratch for, for high novelty. You want to develop your own model from scratch. That's equally a way to go. Okay. Now, how do we perform experimental design? Basically, you have experimental framework, and this you design a clear experimental framework. Like I mentioned earlier on, when you look at existing, one of the beautiful things about looking at existing literature is the fact that you get to see the approach that was adopted in the existing literature. You get to see what methods they used, what data sets they used. You get to see the different things they did. And then based off those, you may be able to see which of the approaches across the different literature appeal the most to you. and they can now choose to adopt or adapt that approach above, say, the others. So yes, so you design a clear experimental framework, of course, based on what experiments you're performing. Then you now get training versus validation split. Of course, you get your data and split the data into an 80-20 or 70-30 and then you now perform cross validation, of course. The K-fold cross validation for robust evaluation just validates your experiment, and then evaluation metrics, pretty important. Based on what are you evaluating your data? So you choose an appropriate metrics for evaluation. So if you're performing, if your problem in question is a classification problem, then you dealing with evaluation metrics of accuracy, precision, recall, and effort score. If your evaluation metrics, if your problem is that of a regression problem, you're trying to find, say, for instance, what should be the price of a 5-bedroom flat in Lekki if I want to rent one. That's more of a regression problem because you're trying to create a figure, for example, right? Uh, you use metrics like the mean squared error, the R squared score, for instance. And then for a generative model, you are having a generative model. You want to be able to generate text or generate images or generate something. Then you have several different metrics as well, like the FID and the BLEU score for text generation, for example. So your metrics are important. Your metrics are what you use for measurements. And then for you have hyper parameter tuning. That is, you want to tune your tuning of your hyperparameters. So use grid search, random search, or automated hyperparameters. Tuning libraries like the Optner, and then the HyperOpt, and then the rate tune, basically. So what happens when we're looking at implementation and prototyping? Somebody was asking just now that do you end your research just in the research on your research bench, or basically you would want to prototype, right? So basically you develop an development environments. You use modern development platforms, of course, like Jupyter Notebook, and then Google Colab is equally a very good environment you could use, especially if resource constraint is an issue. And then we also have iCharm, an IDE, and that could be used as well. The libraries like you could use for machine learning, deep learning, you have like TensorFlow, PyTorch. We know all these already. Then for NLP, you have Transformers, Hugging Face, Spacely, and all that. And then for basically other things, data science related, machine learning, pandas, NumPy, SciPy, and for visualizing our data, we have Matplotlib, Seaborn, Plotly. Basically, we have this, and we could easily use them. Before do we have any questions? Okay, none for now. Okay, let's round this up. So now, we are all familiar with source control, version control, and collaboration. So if, for instance, you're working collaboratively on your research, you control your version, or even if you just want to be able to have control your versions, this is applicable to both your write-up and your code. You could control your versions on a repo, right? And this could help you have a backup. There are cases of people having done their work to a large extent, and in between they lose something, maybe their laptop, and the work is all gone. So two ways you could do this. You could do your majority of your work in the cloud. You could use things like Docs for your write-ups, for your summaries. So in that case, even if you lose your laptop or your machine, you could still have your work in Google Docs, and so you don't get to lose that. Or you could just create a Git repo and back up both your write-up and your code in your repo. You could use GitHub, Bitbucket, GitLab. Basically, use the one that works for you. I believe we're all familiar with this. Yeah, I believe we are all familiar with this. I mean, we are computer scientists, we are cybersecurity professionals. So I know we're familiar with this. But if you're not familiar with using GitHub, GitLab, using version control tools, you could just let me know. That could be something I would just put up. We just put up a short lecture for that, put us through how we can leverage this. But if that would be an added workload, you could just simply use Google Docs or a similar cloud-based tool to get your work done, and that puts you in a good place. All right. So now, publishing and dissemination. Basically, you look for top-rated journals. You can publish your works there. I gave you a list of the different journals available, and then you could apply for something. I give you a series of different sources. Okay, some good outlets publish your work include, say, things like Journal of Machine Learning Research or IEEE Introduction on Neural Networks and Learning Systems, say, pattern recognition letters, neurocomputation, conferences like basically ICML or ACL or CVPR or ICLR. You have these already provided, right? And then you could have for open science, you could share code, data sets, findings via platforms like Zenode, Kaggle, the different data repositories we've already mentioned earlier. You could equally share your data sets you generated using those platforms. You could find funding from different sources: National Science Foundation, the Horizon 2020, Google Research Grants, AI for Earth by Microsoft, and so on. Basically, you ensure that your research addresses real-world challenges that appeal to funding organizations such as sustainability, healthcare, financial inclusion, or education, which are part of the reasons why I'm giving us the topics we have, because these are topics that address real-world issues, right? And I believe there are topics that will equally be able to attract research as well. Okay, so let's be right quickly now. Um, Ethical considerations and responsible AI. So you have to ensure that your work aligns with AI ethics and responsible AI guidelines. So you have to address bias in data sets and model prediction. You have to build your system that prioritizes privacy and security, promotes transparency and fairness in AI systems, and follow fairness, accountability, and transparency guidelines in your research, especially for large language models and Gen AI systems. And then, of course, we encourage continuous learning. So this is first in its series, and we'll be having many, many more of this coming up. So yes, if we have any questions, let's feel free to ask at this point. Otherwise, we would have come to the end of today's session. So are there questions that we need to attend to before we close the day? Any questions? Are there any questions? The comment section here. So if there are questions, please just ask. Okay. Okay. It seems like we all understand what we've discussed. So, if it's been a fantastic evening, and yes, please enjoy the rest of your day. All right. No